Mic check. Okay. Good morning. Morning. It looks to me like the midterms went pretty well for everybody, so that's great news. I was glad to see that the results were pretty good for everybody. So good job on that. Good morning, Justin, and good morning to whoever else managed to make it. I don't know what the power situation is like. Hopefully, you all have your electricity. But if you're watching this later, then hopefully that settled itself out quickly, um, and that you're back to sort of your normal routine. So we're in week 10. We are way past the hump and coming down. Officially, we're the second half of the semester, but really we're past the halfway point. So that feels great. Uh, Morning, Linkridge. Morning to you. I have a small audience today, but good morning to anyone else who's watching. So before I start, just sort of do my normal walkthrough. Um, if you don't have your CentOS system running, go ahead and launch it. Probably you're already in the habit, but go ahead and launch it before I do this walkthrough. But don't log in because we're going to log in as root first and do a little thing. So that we can do some maintenance on our systems and also build up for what we're going to do next week. So anyway, go ahead and launch your CentOS systems, but don't log in as normal because we're going to log it as root and make the change, and then log out and be our normal user. Okay, so anyway, if you can have that going in the background while I do my walk through this week's module, that would be great. Okay, so we are in week 10. We're 2 weeks out from the team project, so on the home page, if you scroll down to the schedule, there's a link to the team project. You'll also find it, I'll show you in the modules where there's a link to it, but there's a link to the team project. I don't have it on my Canvas, but on the left, the gray bar on your Canvas, there should be a groups link. And if you click on the groups link, you will find that you have a Team Project 1 group that you've been attached to. And if you haven't done so, now is a good time to get in touch with whoever will communicate with you and get the team project going. It's not a hard project. What it asks you to do is for your team to get together and pick a Linux distribution, preferably one that you haven't seen yet. So you've seen Lubuntu and you've seen CentOS. So your team project should be to pick an alternative Linux distribution, install it into a virtual machine and explore its capabilities a little bit, and then do a little bit of web research about it. So if your team hasn't been communicating, I think some of you have. It's weird in Canvas though, I can't actually see most of what your team communicates. So hopefully you are. It's 2 weeks out, November 8th. There is a template in there, which is basically a text document that you fill in by addressing some of the questions I've asked based on your experience exploring a different Linux distribution. The main idea there is, well, there's two. One of them is to get you to interact with your classmates a little bit, which we don't do nearly enough of when we're online. But also to give you a chance to realize that your Linux skills translate to all of the different distributions and the Unixes. If you pick a Unix to install, you'll find that your command line skills all work the same everywhere. So it's meant to increase your confidence about doing works in Linux or Unix type systems. Okay, so we are in week 10. We're doing permissions this week, which doesn't sound all that exciting, but I think it's kind of cool the way it works in Linux. So hopefully in our experiments you'll find that it's also, hopefully you find that you also think it's kind of cool the way it works. All right, so let me walk through the week 10. So we're going to talk about permissions on files and directories. The way you control access to files versus access to directories is subtly different, and making sure you understand how, for example, having read permission on a file is slightly different from what it means to have read permission on a directory. We'll use the ls command with its long listing option to see permissions on files and directories. We'll use the change mode, or what I usually call chmod. We'll use the change mode command to change permissions on files and directories. And then we'll explore what it means to have the different permission settings on files versus the different permission settings on directories. If you are a system administrator type, this is particularly important because it's one of your more fundamental security tools in Linux, is to properly set the permissions on files and directories. If you are a developer type, you need to know about permissions in part so that you can install software for yourself and get it to run. But also, for example, if you're building a website, you need to know your way around file and directories permissions often, because you're going to load content onto a web server, and if the permissions aren't set properly, then people in the world won't be able to view your content. I'm thinking we're going to install a web server in the last week or next to last week, and then you'll see some of that in action again. Okay, so readings as usual, and the lab questions are all written against those readings. The lab assignment itself. So this week the Piazza discussion, which a few of you have already weighed in on, but what we're going to do next week as sort of a bonus content is we're going to install what's called a window manager. It's kind of bonus content, but I think it's useful when you're operating in the Linux world to understand the different kinds of graphical user interfaces that you can provide your users. So we're first going to do window managers, and then later in the semester we will do desktop environments, and they're different. It's two different things. So your Piazza discussion is in preparation for next week's class, installing a window manager, for you to do a little bit of research to understand what a window manager is, and then vote on a window manager that you would like to see us do a hands-on walkthrough with. And then last, the reminders. So on the reminders page is another link to the team project, and then the usual content. So that's where we're at for this week. All right, let me switch up the view, and lost my train of thought for a second. Oh yeah, I want to switch up the view, and let's go do the quick little root thing. So we're going to need this setting for next week. So if you're watching the video later, this is, I'm going to assume next week that you've done this part. I will mention the fact that this part needs to have been done next week, but if you don't do this part this week, and I will assume that you did, then next week won't work perfectly. So do this part this week and get it out of the way. So here's what we're going to do. We're going to log in as root. And you can confirm, of course, with who am I, that I'm in fact, so I'm logged in as root. Remember, you need to be careful when you are operating as root. Be particularly careful with the rm command, because like we've actually sort of discussed by chat on a prior lecture, you can wreak all kinds of havoc. You can completely destroy your virtual machine or a production machine in the real world if you use the rm command irresponsibly. Another command that we're adding today, the change mode command, you can also wreak havoc and create massive security holes on your system if you use that irresponsibly. So be careful of these things. But the reason we're here is because we want to give our normal user the ability to update and install software. We don't want to have to log in as root every time we want to do a little bit of maintenance. So we're going to make our user account be a special administrator account with the ability to elevate its privileges. So the way we're going to do that is with the command called vi sudo. There are other ways to do this, but when your system has this command, this is considered the proper way to do it. So this is going to edit the sudoers file. After we edit it, we'll go look at the permissions. So the trick here, and I'll go slow, is to be careful that you don't make typos. So what vi sudo does is it opens a file with vi. And the file is called the sudoers file. sudoers, the sudoers file. So this special command opens the sudoers file in vi. So here it is. It's vi, so you can move the cursor around. I'm using J to go down, K to go up. So there's a whole bunch of scary looking stuff in here. I'm going to actually, I'm going to scroll down until I find the thing that I want, and then I'll give you a chance to catch up. So what we're looking for, I'm just going down with the J's. We're looking for this line right here. Hopefully you can see my mouse pointer. It says root, and then there's a tab or something, all equals all. So that's the line that we want to put the cursor on, and I'll give you a few seconds to get that. So vi sudo open to this file, and now I'm using the vi editor to edit it. I'll add this to my notes. So we're doing a part 1 here. Then we're going to write and quit, and then we're going to okay, so we're in part 1. We logged in as root. We used the vi sudo command to edit the sudoers file, so that's where we're at right now. You want to find this line that says root all on it. And then we're going to do this. We're going to YY. So YY. Then we're going to P. Command to paste the yanked or copied line. So I already did YY, now I'm going to do P. And what you'll see is I get a duplicate of the line. That's what I want. So YY, once you're on this line, so the cursor needs to be on that line. P to paste a copy, and what it does is it pastes it on the immediate line below it. Then we're going to change, and you can do this however you want to. The way that's most straightforward for you if you haven't been using VI for very long, make sure you're in command mode. So X, that deletes the 4 characters of root, and then I'm going to go into insert mode. And you can see at the bottom of the screen that it knows that we're in insert mode. And then I'm going to type user. And then I'm going to hit escape. So notice I'm in insert mode, but I'm going to hit escape, and I'm going to get out. So what this does is it allows your whatever you called your account. Mine is called user. So the username of your main account that you use, that's the name that goes here. So mine is called user. On most systems, by the way, I'm jboyd is what I usually have as a username. But on my CentOS, my username is user. So anyway, now my user account can elevate privileges and run commands anywhere. So now user is kind of an administrative user. It's not root. It doesn't have all the power of root, but it has a lot of the power of root now. And then make sure you're in command mode. And then from command mode, escape, colon WQ to write and quit. And then you'll notice that it wrote a file called sudoers.tmp. So hopefully this just does what we want. Okay, so now I'm going to log out. And then I'm going to log back in as my regular user account. Alright, just showing you what I'm doing there in the notes on the side. So I'm logged in as my user. So let's use the man pages. I'm adjusting my screen. Okay, so let's use the man pages to see what sudo is. Okay, so technically it is execute a command as another user. Now, we are actually using it to super user do. So I think of it, and that's probably what it actually means. When we want to perform a task as the super user, we want to do something as super user, sudo is the command to do that. The reason why we just logged in as root is because if root has to provide permission for other people to sudo. So if you want to use this command, you have to be a sudoer. So hopefully that all comes together. I wanted my regular account to be a sudoer, so I logged in as root. I edited sudoers to make my regular account be a sudoer, and then I logged out, and now I have logged back in as my regular account, and now I can do things as a sudoer, which we're going to need next week to install some software. So now my regular user account is a sudoer. At least should be. So we're going to try it and make sure it works. So the first thing we're going to do, well, let's try like this first. Just do yum update. And then you get an error because you're a regular user and it needs to be run as root. So the whole thing that we just did with sudoers is that now my regular user can temporarily elevate its privileges. So I'm going to sudo this command, which means I'm going to run the yum update command as the super user, and I just gave myself permission to do that. It asks you for your password, so your user's password. And then you can execute a administrative command. So all I did was a software update, and I guess I've done one at some point in the not too distant past, so I'm not taking any updates. If you're taking updates, just let them take. So now that we've given our regular user account sudo power, when we go to install some software next week that will require root user level permissions, we will be able to sudo to do those installations. So that's why we went through all that. It is related kind of to permissions because sudo gives a regular user the ability to execute, the permission to execute some commands with elevated privileges. Now for our sudoer, this command, we gave them the permission to do everything just about that root can do. If you're a system administrator, you would usually you would limit sudoing to specific tasks, perhaps like adding and removing files from a specific directory on the system. But in this case, we gave ourselves super user privileges that go all the way up, basically. So we have this one sort of special account that can run individual commands as root. Okay, that's a lot. That whole thing, part one, was the sudoer stuff. You need that completed, and this sudo yum update was a way to test it that you're looking at my screen right now. So yum update without sudo, I got an error because I don't have privileges. Yum update with sudo, now I have temporarily elevated my privileges and I can run the software update command. I happen to take no updates. You might get updates, it's fine. Just let them go is what I recommend. Okay, so that's all we need to do for part one, and that gets us set up to more quickly go into the fun stuff next week. But it's kind of a permissions thing, so it's also setting the table for what we're doing this week. Okay, all done with that. Now let's do actual permissions. So when you run the ls command, you get a regular listing of regular files, and you know that you can do the -a command, which will list all files, including the hidden files, which is the dot files. So we're going to add an option this week, which is -l. And the -l gives a long listing, and the long listing adds a whole bunch of new information to it. So what we're most interested in is the stuff on the left, but there's also the user associated with that file or directory is the first column. The second column is the group associated with that file or directory. So on the CentOS system, when we created a user account, it also created a group for our user account. But in a real system, you would probably have like your web developers in a separate group, and users can have multiple groups. So you would add your developers to a web dev. You might have database administrators in a DBA group. So in a system administrator's perspective, groups is a layer of security you can add. You can attach people to different groups, and then you can give permissions to those people as individual users or as members of groups. The third thing is the size, probably in bytes. The date of last modification, date and time, and then the name of the resource. But for us, what's interesting about and what we need this week from the long listing is the permissions stuff. Okay, so what you'll see, and I'm going to do this on the notes on the side, what you're going to see from a long listing. Can I make this taller and not mess you up? Oh, I can make this. Let me see if I messed it up on the screen. I did a little bit. Okay, so what you're going to see when you do this long listing is a first dash or character. So you'll notice some of them say dash and then an R, and some of them say D and then an R. So the first character tells you what kind of thing that it is. So a regular file, like a text file, will just have a dash. Directories have a D, and there's a few other resource types out there. Okay, just check and chat. And then you're going to see 9 more entries, and I'm going to separate them out. So in total, there are 10 columns, and these are, the first one is the type, and then the others are the permissions associated with a particular layer of organization. So the first one is the user permissions, the first 3. So if we look at my file2.txt, the dash, the first dash is that it's a regular file. Then that R means that the user, which is the owner, user is the owner has read permission on that file. The owner has write permission on that file, but the owner does not have execute permission on that file. That's the first 3. The second 3 are those same permissions, but as they apply to whatever group has been attached to that file or directory. So the second triplet, the group has read, the group has write, and the group does not have execute on that file. And then the third 3 we call other. Some systems or admins will call that world. Other is everything else and everyone else that's not that user and not that group. So other is the rest of the world. And you'll notice that the rest of the world has read permission on that file, but not write or execute permission on that file. So that's how those triplets work. The type, and then a triplet for the users, read, write, execute, a triplet for the groups, read, write, execute, and a triplet for everybody else's, all others, read, write, execute. And they always go in that order, so it's RWX. If there's a dash, then they don't have that permission. If there's a character there, then they do. Okay, so that's the view. So you can see all of mine have the same read, write, and execute permissions. We're going to come back to how do those default settings happen. But for now, let's just worry about the permissions themselves. So when you create a directory, it will be created with some default permissions. So if you look at my week 11 directory, the D, the first column, means that it's a directory. That looks not quite, I guess it's okay. So week 11, and then the user, which is me, I'm the owner, has read, write, and execute permission on it. The group has read, write, and execute permission on it. And then all others, the rest of the world, has read and execute but not write permission on it. Okay, so now let's go play around with changing those permissions up a little bit. So the way you change permissions is with the change mode command, or chmod. So let's bring up the man page and look at it. This command I struggled with for a long time. Hopefully I teach it in a way that most people sort of don't struggle with it as much as I did when I was trying to figure it out for myself. But if you read this, the man page doesn't feel all that helpful because it's just really just a wall of words. If you read it carefully and you learn how to read man pages and make sense of them, then you can make it work for you. But don't worry if you look at the man page and you think, I don't know how to make sense of any of that. So let's just talk about it, and then if the man page helps you, then it does help you. But the basic idea of the change mode command is, let's pick one. So let's do, I'm just going to get the long listing specifically for that file. So we're going to change mode on it. And we're going to use letters mode first. So in my notes, that's down here on line 26. So we're going to use letters mode with chmod because I think that's the easier one to figure out. So the letters mode allows you to add permissions, subtract permissions, or set permissions as you want them. So let's do one. Let's subtract a permission first. So if we notice here on file 2, in fact, if you don't have a file 2, just do this. Let's make a directory and let's go do something clean. Let me see if I have a directory for this week. Thank goodness I don't. So let's make a directory for this week, and then we'll go into a directory that's completely clean of content and just work inside of there. So I'm going to make the week 10 directory, and then I'm going to switch into it. And so now there's nothing here, and that's we want a nice clean view of things. Okay, so I'm in my week 10 directory. There is nothing here. That's what I want. So I'm going to touch a file, and I'll just call it file.txt. And then do a whole bunch of experiments on changing the permissions on this file in different ways, seeing what the implications of changing the permissions on this file is, and so on. So now if I do an ls, of course, it'll show me the file. To see the permissions, I will do ls-l, and I will note that just like all the other files I've created up to this point, the first dash means it's a regular file. The user, the owner, has read and write but not execute. The group has read and write but not execute, and all others have read but not write and not execute. That's what those permission settings mean. So let's use change mode to start taking some stuff away. So you can in letters mode, so this is where we use letters to refer to the things we want to change. So I'm going to subtract from other, so other minus, and I'm going to take their read permission away from them on that file. So O minus R means from other subtract read. Now if I do -L, you'll notice that the read permission has now been taken away from not the user and not the group associated with the file, but all others. Which is the tightest security setting you can have, is to remove all permissions, which would mean that anybody who's not that user and anybody who's not a member of the group associated with that file can't do anything with it. They can't read it, they can't write to it, they can't execute it, they can do nothing with it at all. Okay, so let's actually do that. Let's take away write. So I just want to show you there's a whole bunch of permutations here. So let's take away the write permission from the user and the group. So you can actually, on the left hand side of what operation, you can say the different categories. So I'm going to say subtract from user and subtract from group the write permission from that file. And now notice they don't have, the user and the group no longer have the write permission. So you can combine them. So we could add things, like we can say, let's have user group and other have execute permission on that file. And now all three, the user who owns it, the group associated with it, and all members of that group can execute it, and all others, everybody else can execute it. This is, for a file, bad security. For a directory, it's a common security setting, but because it means something different, but for a file, this is bad security, especially if there's something that can be executed in it. Okay, so showing you letters mode. If you want to refer to all three groupings, you can just say all, and that refers to UGO. So you can say UGO, but you can also say all. And let's, in this case, let's give everybody the same permission. So we can say all is exactly this setting, and we'll give everybody read permission and nothing else. So now everybody has read permission and nothing else. So this is called letters mode. I'm going to do a couple more experiments with it, and then we'll see what the implications of these permissions are. Just with our own user. Okay, so let me clear the screen. Remind you where I'm at. I'm in my week 10 folder, and I have one file in here that I have the permissions set. The user has read, not write, not execute. The group has read, not write, not execute. Others, all others, have read, not write, not execute. And we're using letter mode, which a lot of people like. I used it at first because I could figure it out faster than I could numbers mode, but once you get some experience with it, I suspect you're going to use numbers mode more. But anyway, letters mode is perfectly valid. So what I'm going to do here is for my user, I'm going to add write and execute permission on that file. And now you'll notice that my user has the full complement of read, write, and execute. The file turns green now because the shell realizes that it's executable, so it colors it up like that. Okay, still using letters mode, and I want you to notice what's special about letters mode is that you can add individual things to user, group, other, or combinations of them. You can subtract things from user, group, other, or combinations of them, and you can set the permissions for user, group, other, or combinations of them. So letters mode is very, very flexible, and it allows you to target specific permissions for user, group, other, or combinations of them. So it's very, very powerful way of setting permissions with the change mode chmod command. Okay, so before we leave letters mode, let's look at what it means to have the different permissions on a file. So the first thing I'm going to do is I'm going to put some contents in it. So right now it's in read, write, and execute. That's what I want. In fact, let's take execute off. So I'm going to take execute off from user. We're going to put it back later. But anyway, let's go. Since it is writable, I can edit it. So I'm going to use VI to edit it. I'm putting this pound sign on purpose, so if you're going to type along, it'll work out better for you if you put that pound sign there as well. So I'm just going to type in a little sentence, but a hash or a pound sign at the front of the line will make the next thing kind of more cooperative. And then I hit escape to get back in command mode, and then I'm going to write and quit. Okay, so the fact that I could actually make alterations to that file is that it had the W, the write setting on it. So since I am the user who owns it and I have write permission, I have the ability to edit it. So let's take the write permission off. And then see what the implications are. So I'm going to open it with VI. So if you notice at the bottom it says read only. So VI is not going to let me make edits to this because I don't have write permission. Even though I'm the owner, since I remove my own write permission, I can't alter it. This is a good security setting to protect files from the world, but even from yourself, if you have an important configuration and you take the write permission off, that could be a way to sort of check yourself when you do some irresponsible edit. So anyway, if I were to try to, so I'm going to hit the O key in VI, which will open a new line. Now I got a warning that says you're in a read-only file, so I'm going to try to do something, and then I'm going to try to write and quit. So I do have an option to override, but I'm not going to do that. I'm just going to point out to you that VI recognizes that there's no write permission, even though I'm the owner of the file. I don't have write permission, so it's telling me you're not supposed to be writing in this file. So let's do a quit and not save. And bounce out of it. So there's the file, still no write permission. And if you tried to do something like this, like run the date command and append it to the bottom of the file, permission's denied because you don't have write permission on the file. So on a file, that's what write permission means. If you have write permission, you can edit the file, modify it. If you don't have write permission, then you can't. It's pretty straightforward on a file. Okay, so I'm going to use the cat command to dump the contents of the file on the screen. You could also use the more command on it to do that, or the less command. Less is actually a pager, so you have to do Q to get out of it. But the reason I'm doing that is because I want to change the read permission. So now I'm going to take everyone's read permission off. So from everybody, A is just a shortcut for UGO. So from all, I'm going to take off the read permission from that file. So now if I look at it, nobody has permission to do anything. So let's see what happens now if I try to cat it out. Permission denied. More it out. Permission denied. Less it out. Permission denied. So read permission on a file literally means that. Can you read the contents of the file? VI, if you noticed, will open the file if you have read permission, but it grouses at you if you try to do any writing to it. So that's what the read permission on a file means. Can I even look at the contents? Write permission means I can alter the contents. And now let's look at what execute means. So let's look at what our our permissions are. So let's add some permissions back. So for user, let's add read and write back. So now I'm read and write back, and I'm going to go now with my restored permissions. I'm going to go edit it. I'm going to type a little O, which will open a new line for editing. I'm actually going to hit enter and put a blank in there. And I'm going to type just going to put a message in there. Mine says this is an executing script. Be careful with the quotes to get those right. And then I'm going to exit or escape to get out of insert mode and go back into command mode so that I can write and quit. So hopefully I slowed myself down enough. You can just put hello in there if you want to. But I'm just going to wait a minute so you can get this stuff. So that first line, line number 1 that has the pound or the hash symbol on it, that's on purpose. And the reason that we did that is because when we execute this as a script here in a second, it will ignore the line with the hash symbol on it. So what should happen when we execute this thing is that it will print out my message. This is an executing script. Echo is print. Okay, so from command mode, :WQ. Let me clear ls-l. So I put some executable code in there, and the way you would execute a script normally is you'd put /. This is a path issue. So in this directory, find this file and execute it. Permission denied. So if you have a file that has executable statements in it, which we would call a script, and probably a lot of you have done a PowerShell script or a command console script, like a, what do you call those? A bat file type script in Windows. Anyway, that's kind of what we're setting up for here. So Linux will not execute this script unless it is executable. So the way you prevent people from executing scripts in Linux is you take away their ability to execute the statements. I think in Windows, for the most part, if you put .bat on the end of a file, it's going to try to execute it. But in Linux, you actually have to purposely allow for execution. So I'm going to use the change mode command. I'm going to give my user, I'm going to add the ability to execute on that. And now you'll notice it's green, which means that the display recognizes it as an executable type, and there's the X showing it is executable. And now when I type file.txt, it'll actually find anything that's executable inside of it and execute it. In this case, it found the echo or printout statement and executed it. Notice that it ignored the hash symbol line, because that's, if you've taken a programming class, that's a comment. Okay, so what does execute mean? If a file is executable, that means that you can ask the shell to attempt to execute it. But this works for any kind of program. So if you install software and you remove all the execute permission off of it, then it can't be executed. It has to have executable permission, or Linux won't allow you to execute it. So that's those permissions on files. Okay, so we've been using letters mode, and letters mode is really good for targeting specific permissions and turning them on and off. So what we're going to add is called numbers mode, and I'm going to have to scroll my notes up a little bit to add some stuff here. So we're going to add numbers mode. And I want to put a couple of extra notes on numbers mode, because when you're doing change mode with numbers mode, it's an all-at-once setting. So you can't use numbers mode to add a specific permission. You have to, when you're using numbers mode, know all of the permission settings at once that you want. So it's less flexible because of that, although I use it most of the time just because it just feels faster at this point and more natural. But when you're using numbers mode, you have to know all three of your triplets all at once. You can't just selectively change one part of the permissions. You have to set them all at once. And there's an arithmetic to it. So the values for using numbers mode are 4 if you want to allow reading, 2 if you want to allow writing, and 1 if you want to allow executing. And what you do is, let's say that you want read and execute, then you would take the 4 and you would add the 1, and you would get a setting of 5. If you wanted read and write, then you take the 4 that's read and you would add it to the 2 that's write, and you would get a setting of 6. If you wanted read, write, and execute, am I going to run out of space? I hope not. That's 4 plus 2 plus 1 equals 7. Let me click this down so I can get it to fit again. Okay. Hopefully I didn't make that too small. Anyway, so if you want all 3, then you do 4 plus 2 plus 1 equals 7. Okay, so that's the arithmetic of using numbers mode to change permissions. The last thing that you need to know is you do it as three numbers. So you have to do the math to get the user numbers, and you have to do the math to get the group numbers, and you have to do the math to get the other number. So let's say, for example, that I want For user, I want read, write, and execute, which would be 4 plus 2 plus 1 equals 7. Let's say for group, I want read and execute. That would be 4 plus 1, that would be 5. And then for other, let's say I want also read and execute. That would be 4 plus 1 is 5 again. So I would do chmod, I would take the user total, 7, the group total, 5, the other total, 5, and then I would apply those to some file. So it's an all or nothing numbers mode setting. You have to compute each total value for the exact permissions you want for user, and then group, and then other, and then you call the chmod command with the user number, the group number, the other number, and then the thing you want to change. So hopefully that makes some kind of sense. To me, this is the harder one, although once you get used to it, it feels like the faster one, and probably you end up using it more. So that's the numbers mode. And we're going to use it on directories. Okay, so I'm going to make a directory. I'm just going to call it subdir1. So there's my subdir1. So if I just sort of do the math in my head, the D means directory, RWX, so for user, that's 4 plus 2 plus 1 is 7. So the user's current permission is 7, 4 plus 2 plus 1. The group's current permission is also 4 plus 2 plus 1 is 7. And then all others are 4 plus 1 is 5. So the setting on subdir is 755. Now I'm actually going to use change mode on it to take all permissions away from everybody. And remember, when you're doing numbers mode, it's all at once. So you can't just selectively change pieces, you have to know all of them. So if I 000 on that subdirectory, all the permissions are gone. So I took them all off. And now I'm going to start adding them back in, and I just want you to notice how that works. So if I want to give just the user read and write permission, then I'm going to read and write is 4 plus 2 is 6. So I'm going to change mode. I'm going to give the user read, write, but no execute. And then I'm going to leave the group as nothing, and I'm going to leave all others as nothing, subdir1. All the settings have to happen at once. And now you'll notice that read and write were added to it. So now let's give group and other the read permission. So let me clear first. So I'm going to give group and other the read permission. So here's the trick about numbers mode. I have to remember what each triplet totals to. So if I want to keep the user at 6, then I have to do that. The first number that I type here is going to be the user's setting. So I'm going to keep it at 6, and then I'm going to do 4, that's read, but not write and not execute. So just 4 for group, and then just 4 for other on that subdirectory. And now the user's permissions are unchanged, and group has 4, which is read, and other has 4, which is read as well. Okay, so how am I doing on time? I'm doing okay on time. So now let's see what permissions mean on directories. It's slightly different, although for the most of it still makes sense. So let's start by taking all the permissions off using numbers mode. So I want no permissions for user, no permissions for group, no permissions for other on that subdirectory. So I did change mode 000 subdir1. So now all the permissions are gone. And let's see what that means. So let's do a let's try to change directories into it. So let's try to change directories into subdir1. Permission denied. So this isn't going to be in exactly the right order, but that's the first thing that you would want to be able to do. You can't change directories into a subdirectory unless you have execute permission. So on directories, execute means can you even enter the directory. So I can't do that because I don't have execute. I'm going to try to, using a relative path, I'm going to try to create, by using the touch utility, a file inside of subdir1. Permission denied. So that's because I don't have write permission. So execute permission on a directory, it gives you the ability to enter into the directory. Write permission on a directory gives you the ability to create files and directories in it. And then you can imagine what read is. So if I try to do a listing of the contents of subdir1, I also get a permission denied, and that's because I don't have the read permission. So read on a directory means that you can list its contents. Write on a directory means that you can add files and directories to it. And execute permission on a directory means that you can enter into it. So let's change some of that and give ourselves the ability to do those things. I'm just going to do the listing on the subdirectory. Oh yeah, I can't do that. Okay, so let's start adding the permissions back. So let's give ourselves write permission first. So if I want my user to have write permission in numbers mode, I want to do write only. I'm not going to add read and I'm not going to add execute yet. And I'm going to leave group and other as no permissions on my subdirectory. So the 2 means I have write permission, which means that I should now be able to use touch to create a file in it. Except for I can't. Didn't I give myself write permission? I did, which I should be able to create a thing into it. That's interesting. Well, let's give ourselves, presumably you have to be able to do read as well. Well, let's undo. So I'm going to change that. I'm going to give myself execute permission only on it. And I'm going to go into it and play around from there. So remember, those settings are all or nothing. So in theory, I think I can go in there. I can. So I'm in there, but I don't have the permission to actually list its contents. And I probably still don't have the permission to create a file in here. I can't. So now let's change the permissions. I'm going to do a all. Oh, I can't do that. Let me go back one. Okay, so I went back one so that I can see the permissions on it. So let's give ourselves write permission now. But I want to leave execute. So when I'm doing numbers mode, I want write and execute, which is 2 plus 1 is 3. Nothing for anybody else on this subdir1. So now I have write and execute in theory. So now let's see if I can, I can change dirs into it. Let's see if I can touch now. Okay, so now I am able to write a file in here, although I can't list it because I don't have read. So I'm going to go back again. And let's give ourselves read. So I'm going to change mode. I'm going to do read, write, and execute. But nothing for group and nothing for other on that subdir. Now, in theory, I can switch into it. I can list its contents. I can create another file in it, list its contents. So now I have the full complement of things. So I did add an extra reading because this as you could see me sort of fighting with the touch command. Even though I had write permission, apparently without execute it wasn't going to let me do it, which is quite interesting. Okay, that's mostly it, I think. So anyway, play around with these things. The one thing I will tell you, I'm going to use CD and go back to my home. No, let me go back one. So this is my week 10 folder that I'm in. But when you create files and directories, there's actually temporary default permissions set on them. So pay attention to that, what the default is. So if I touch a file, I'll call it file2.txt, you can see that it's set. There is a default settings, and we'll come back to this at some point. But notice that when you create files, there's default permissions set on them. So user has read and write by default. Group has read and write by default, and other has read by default. You will never see a file defaulted with executable permissions. In fact, I don't even think it's possible to default something to be executable. And then also experiment by making a new directory. And notice the default permissions on directories are much more forgiving. So the user has the full read, write, and execute. The group has the full read, write, and execute. And other has read and execute. Those are the defaults when you first create a folder. The defaults can be manipulated to a certain extent, and we'll do that a little bit later. Okay, so that's numbers mode in the change mode command. That's letters mode. Hopefully you have time to play around with the different permissions settings to get a feel for what they do and don't do. The directories ones are the funny one. The file ones are fairly straightforward. Read means you can look at it. Write means you can edit it. And execute means that if it has something that can be executed, it can be executed. On directories, read means list the contents. Write means create new contents in the directory. And execute means you can enter into the directory in its basic form. Okay, so that's all I got. Thanks for being here. I hope I hope the pacing was okay. If you're a sysadmin type, this is one of the biggies for you, is this permission stuff. Since it is sort of your first sort of layer of control over the security of your system, is simply is good permission settings. Anyway, that's it. So I hope you have a great week this week. It'll be fun to put some graphics on here. So we're gonna please, if you're watching the video later, please stop it and do part 1 where we did the sudoers thing, because we need to be sudoers to make our lives go a little bit easier next week. So the Piazza discussion this week is you guys voting on a window manager that you would like to see us install, and then I'll take the results of that vote and we will install 1 and maybe 2 if it's close and we have time. But we're going to install a graphical user interface, the very basic one, and talk about what a window manager is, and that should be fun and satisfying, I think. It will be for me. I hope it is for you as well. So that's what the Piazza discussion is. Anyway, have a great week. I'm looking forward to next week because we get to put some graphical user interface in here, which should be fun. And otherwise, I'm out. So take care, and I will see you again on Tuesday morning. Thanks, Justin. See you next week as well.